how do we tell a mineral from another mineral? And so today we're going to start and talk about a few. One of the basic characteristics is that of hardness. A man named Moe developed a series of hardness levels. These are the ones that he developed. Talc being the softest, all the way up to diamonds, which is the hardest. And the way that they did this is to test them by scratching each other. So the very first one, talc, is this mineral right here. Sometimes it's referred to as soapstone. You can scratch it with your finger very easily. And talc used to be talcum powder used for babies. Now, the biggest industry that uses it is the cosmetic industry. So talc is a very important material. Without it, we would not have many of our cosmetics. One of the other is calcite. This is calcite. It can be scratched with your finger. And so calcite, and one of the others, which is very common, is selenite, which is gypsum. It's very easy to just scratch gypsum with your hand. These have very different characteristics. Gypsum or selenite normally doesn't make fantastic crystals. Why calcite, one of its very famous things is that it has rhombohedral crystals. If you bust it up, the crystals are exactly the same as the larger one you just broke off of. So this is an important feature of minerals. Another characteristic of minerals is they may form crystals. This is a quartz crystal, and because of its six-sided nature on top, it's very easy to identify. One of the other things about quartz is it is transparent, and you can see through it, but not all quartz is. So you have to be careful when you go to identify minerals. Sometimes these tests are just mere indicators of how you might find them. One of the other characteristics is if it doesn't form a crystal, it may form a mass like this. And when we break it or hit it, it makes these conchoidal fractures. So some minerals fracture rather than cleave. Cleave means to break along certain planes. So certain things like mica cleaves in a flat plane. We just talked about calcite that goes rhombohedral. But some minerals, when they break, they do this. Sometimes when you look at things like obsidian, you realize, hey, that has a great example of conchoidal fractures. Another one which has those is chert. This is a sample of chert. Now, chert was used a long time ago like flint. You spark it, but it's because of these conchoidal fractures. Obsidian and chert were both used for arrowheads. So when you're out looking around and you see some arrowheads, they may not be black. They may be tan like this, and they're made of chert. So that's another characteristic that we have of minerals. Another characteristic is what we call luster. This one has luster. And as you turn it, you see all sorts of the colors of the rainbow. This is opalized shell. And opalized shell has all the colors of the rainbow in it. But again, that's a characteristic that we can use to identify what the mineral is. Another example of a mineral that's very unique is this mineral right here. This is labradite from Labrador. And if you just catch the light right, you can see that it has this iridescence like a peacock's feather. This iridescence is, again, a mineral characteristic. Labradite is world famous for this shimmering or phosphorescence appearance as the sun hits it at different angles. Another one of the characteristics, and this is a good example, this shows a luster again. This is what we would call a metallic luster because it looks like metals. But this one is not only just a metallic luster, it's also a mirrored luster. This is pyrite from Spain, and it is called mirrored pyrite because each surface is mirrored such that it really catches the rays and reflects them back so that you can actually see something in it. That's why they refer to it as a mirrored surface. But again, it's another example of luster. In this case, it's metallic luster. So we see that there's lots of different ways that we can detect elements and minerals. One of the other ways that's really important is radioactivity. And I have a sample here, and this is a Geiger counter. Geiger counters were used when they first started finding uranium in Utah and throughout the Southwest. Now this sample has a few examples of radioactivity. I'm going to show you that each mineral can be detected by this method. So if we take another one, in this case, a uranium sample, watch the needle go this time. It goes very fast because it's much more radioactive. Again, a characteristic of some minerals is that they are radioactive. And that's an important feature, especially if you're looking for uranium, to go out into the field and use a Geiger counter to find them. Another characteristic of minerals is that they may be magnetic. In this case, this is lodestone, a type of magnetite that is itself magnetic. So what we have here is we have pieces of iron filings that to demonstrate to you that in fact this material is magnetic. The very first magnets were made from magnetite that was specialized, called lodestone. And so our first magnets were lodestone. And so that's another characteristic of minerals. Okay, what we'd like to do now is we would like to go and check one other type of characteristic. We want to go look at ultraviolet light and show phosphorescence of a mineral sample. One of the other characteristics of minerals is under ultraviolet light, minerals may tend to fluoresce or show colors. This is just a common rock that we have here, as most of these are. When we shut the lights off and allow the ultraviolet light to hit them, you will see a great change in the lights. And again, this room has to be special because we do have to have the lights off in order to use the black light or the ultraviolet lights. So we're going to do that now, and we want you to look at a couple of samples specifically that we have in our collection. One of the samples is this example from Franklin, New Jersey. It's called Wilmanite and Franklinite. It's very characteristic. The natural color of this rock is a light white and a darker tan. But you see underneath ultraviolet light, it has bright red or orange and also bright green. Another characteristic, this is the rock that we picked up to show you in the first place. And now if you look at it, you can see that it has, in fact, a characteristic of fluorescing. This is shortwave. This one over here is mid-range. It means it's not quite as powerful, but still it has a good indication that color can be indicated using ultraviolet light. The unique thing about that is some minerals will fluoresce under shortwave, which we just looked at, some under mid-range, and others will fluoresce only underneath long-wave. This piece of uranium glass, which is really unique, fluoresces underneath long-wave radiation only. And so the ultraviolet light, if you were to take this and put it over in shortwave, it wouldn't fluoresce. So that is another characteristic of minerals.